So you just can't get enough acid, huh? You know, I really don't think you should be telling me that as your teacher. It's kind of inappropriate. Alright, so strong and weak acids and bases and the pH scale. That's a lot of ands, a lot of stuff here. Alright, so these two illustrations show particle views of 0.010 molar hydrochloric acid and 0.010 molar formic acid. The water molecules are not shown. Take a moment to examine them. So the white is H+. They're both acids, so they're both giving away H+. This is HCl. This is the formic acid. I don't see any HCl's together. Some of these ones are still together. Actually, a lot of them are. Only some of them are apart. None of these are together. Okay. Notice there are no molecules of HCl in the solution on the left. I noticed that. The HCl has dissociated, right? Broken apart. Dissociate from your girlfriend or boyfriend while you can. They're much better in college. Completely into H+ and Cl- ions. However, the solution on the right contains formic acid molecules. Right, yeah, and it didn't. Only some of the molecules have dissociated into ions. Most of them didn't. This means the concentration of H+ ions is smaller, so less acidic, in the formic acid solution than in the hydrochloric acid solution, even though they have the same molarity. Right, they have the same concentration of acid, but not the same concentration of H+, I guess. Acids that dissociate completely in solution are called strong acids. So they're good at dissociating. Strong acids include hydrochloric acid, HCl, nitric acid, HNO3, sulfuric acid, H2SO4, and hydrobromic acid, HBr. Strong acids are good conductors of electricity because they have so many ions in solution. Acids that dissociate only partially in solution are called weak acids, so like formic acid. These solutions are only moderate conductors of electricity, so not that good. Some common weak acids are formic acid, acetic acid, citric acid, and phosphoric acid. Weak acids tend to be less corrosive because they do not dissociate completely. So if you spill vinegar on your hand, it's not that big a deal, just wash it off. But if you spill, concentrated HCl on your hand, wash it off really fast, because that's a problem. Bases can also be classified as strong or weak. A strong base dissociates completely, so strong means dissociate completely into ions in solution. Weak bases dissociate only partially. Some examples of strong base include sodium hydroxide. So the sodium hydroxide, the OH-, the hydroxide would come off completely. Complete dissociation because it's strong. Barium hydroxide would also be strong. Weak bases, ammonia and aniline. Aniline? I don't know. Okay, so they don't absorb H+ completely. So that's strong, weak bases and acids. The pH scale is a number line that assigns number values from 0 to 14 to acids and bases. Substances with a pH below 7 at 25 degrees C are acids. Okay, so less than 7, acids. Less than 7, acids. Substances with a pH above 7 at 25 degrees Celsius are bases. So above 7, bases. Below 7, acids. Substances with a pH at or near 7 are considered neutral. Okay, stomach acid is extremely acidic with a pH around 1. So that's really strong, barely corrosive. Which is why if you throw up, it burns your esophagus, burns your throat. Lemon juice is the next most acidic substance shown here. Okay, so here's stomach acid, lemon juice. Those are both strong acids. pH of 2.4. It's getting close to being a weak acid, actually. It's just really concentrated. The most basic substance shown here is drain cleaner. That's like a 13. Really, really basic. But still corrosive, still dangerous. The substances on either end of the pH scale are potentially more dangerous and more toxic than substances found in the middle of the scale. So salt, All right. Now notice rubbing alcohol, you still wouldn't want to drink it. It's a different kind of hazard. It's not acidic or basic. It's just alcohol is also poisonous. So extreme acids and bases are toxic, but that doesn't mean everything else is not toxic. So just keep that in mind. Okay, come with questions and key points ready. Stay beautiful. Bye-bye. I know I'll be staying beautiful. Of course, I don't really have to try. Not saying that I'm going to stop.